Hey there, we're going to now do example 12. Let's have a look here. Consider the function defined by f of x equals to 2x minus 4 for all x element of R. So essentially they're saying sketch a linear function where x is an element of R, meaning any number that you can think of, that's what the x values can be. So part of A, you can see that they want you to find the value of f of 2 and f of t. Me personally, I would normally just do it on a CAS, but I want to show you how to do it by hand. So here we do f of x equals to 2x minus 4. That's your function. There is no limitations based on the domain. So to answer the question for part A, when they say f of 2, all I'm really doing is I'm replacing that x value with the number 2. So I should get 2 times, instead of x, it is now 2 minus 4. So 4 take away 4. Gives you 0. Notice the way I lay it out. I got the function, then I found what f of 2 is, and I wrote it down. Whatever I do as my modeling technique, you should try to do that as part of your habits as well. Okay, it's good habits for Saxon exams. Part B, they say, I realized that I need to find f of t as well. So f of t simply just means I'm going to substitute t into the function. So it'll be 2 times t minus 4. And that just gives me 2t minus 4. Okay? And then we go to B now. Find the value of x for which f of x equals 6. So they want you to find what would x be if the function equals to 6. So the thing is, we know what f of x is. F of x is defined as 2x minus 4. That's what f of x equals to, right? So if that equals to 6, well then now you've got an equation to solve where you can say add 4 on both sides, and then you get 2 times x is equal to 6 plus 4, which is 10. Negative 4 plus 4 cancels out. And then the next line is you'd say divide 2 on both sides, and you now get x is equal to 5. Okay, so I've solved for x, and essentially back in year 9 you would have done this problem by simply saying if y equals to 6, find what x equals to. That's what they're trying to do, and the function is y equals 2x minus 4. That's what you did in year 9. They're now just changing the function, the notation to it. Okay? There you go. So that's B. Let's have a look at C now. If we were to do C, what is that? Find the value of x for which f of x equals 0. So same idea again. If f of x is equal to 0, they're telling you that f of x, which we're already defined as 2x minus 4, and if it was equal to 0, I'm just going to fix that because it looks like a 6, then find what x is. Yeah, they said find the value of x. So now I'm just going to solve it. So I'm going to add 4 on both sides again because that's a minus 4. Add 4 on both sides. 2 times x is equal to 4. Divide both sides by 2. And you can see 1x is equal to 2. Okay, so part B, part C done. Let's do part D. Part D says here that for what values of t is f of t equal to t? So f of t to equal to t. Well, we've already found in part A what f of t is. F of t was 2t minus 4. True? And we want that to equal to t. That's all I'm doing. I literally am just replacing what f of t is, and that's meant to equal to t. But once you do that, can you see how now you've got an equation where you can rearrange and you can say add 4 on both sides, and that will give you 2t is equal to t plus 4. And then if you say subtract t on both sides, can you see t take away t on the right hand side will cancel out and you get 4, whilst 2t minus t here gives you t. And so t, there's a lot of t's here by the way, but that means t equals to 4. And that answers the question, find the value of t or values of t if f of t equals t. And if you follow E, let's do E. For what values of x is f of x greater than x? So they want you to find f of x greater than or equal to x. And again, we know that f of x was defined as 2x plus 4. Or was it minus 4? Minus 4. Whoops. My bad. Minus 4. So if you were to rewrite it, this essentially just means 2x minus 4 to be greater than or equal to x. Now, normally I tell you that you should sketch this graph because when we're doing inequalities, remember with quadratics, the only way to do it is you have to sketch it. But because this is linear, you can probably get away with it, and you can just solve for x in this case. So if you solve for x, minus x on both sides, and you'll get x minus 4 is greater than or equal to 0, and then add 4 on both sides, and x is greater than or equal to 4. I personally don't want you to go through that way because that avoids you from remembering or understanding that when you're working with inequalities, you should sketch the graph. So I would encourage you to sketch the graph of 2x minus 4, and if you minus x on both sides, you would be sketching the graph of x minus 4. So x minus 4 would mean that you would have a 0, -4 as my intercept, and then that x minus 4 would then imply that you get a 4, 0 as well. And then if you sketched it, it should look something like that. Okay, and then now you can say, for what values is it greater than 0 or equal to 0? And you can see this is the only part of the graph that is greater than or equal to 0. That means that the portion of the graph that you want is from 4 onwards. That's why you would say x is equal to 4 or greater to get that portion. Okay, so I would say sketch it is a good habit to do, but you can do this only if it's a linear function. Okay. And then finally, f, for what values of x is f of x less than or equal to 3x? So it's the same drill again. I'm just going to give myself a bit more space. So I'm just going to enter it down. So f, on the other hand, you want f of x to be, what was it again? Less than or equal to 3x. And same thing, f of x is 2x minus 4, less than or equal to 3x. Collect all the x's to one side to help you. So I would probably say minus 2x minus 2x. And that gives you -4 is less than or equal to x. And then add 4 on both sides. And you'd get 0 less than or equal to x plus 4. And this is where I would sketch it. So I would normally do a rough sketch. This would imply that there's a y-intercept at 0, 4, and the x-intercept at -4, 0. Positive gradient. So this is what my graph looks like. So when they say they want it to be less than or equal to 0, that's what the question's asking. When is the graph less than or equal to 0? Well, it's down here. So clearly from the graph, I would then say, therefore, it has to be from -4 to infinity. So -infinity up until 4 is what you want. Or technically, you should be writing it like x is an element, or x is less than or equal to -4, essentially. Okay, but yeah, you can solve it, and you probably could have just stopped it here, and then that's your answer. But like I said, I would want you to get used to sketching and then analyzing the function. So that's probably what I would encourage you to do. But either way, that's how you do example 12.